Forecasters across Oklahoma say the duration that snow remains on the ground depends on a delicate balance of temperature trends, sunlight, wind, and soil conditions, all of which vary widely across the state, making a single statewide timeline impossible. According to meteorologists, northern and western Oklahoma are likely to see snow linger longer than central and southern regions, primarily because these areas often experience colder overnight lows and weaker daytime warming after winter storms. In many cases, snow that falls during a strong Arctic outbreak can remain on the ground for several days, especially if daytime temperatures struggle to rise above freezing and cloud cover limits solar melting. Forecasters note that when high temperatures remain in the upper 20s to low 30s Fahrenheit, snowpack tends to compact rather than melt, allowing it to persist longer, particularly in shaded areas, fields, and north-facing slopes. In contrast, when highs reach the upper 30s or low 40s, melting accelerates quickly, even if overnight lows still dip below freezing, creating a cycle of daytime thawing and nighttime refreezing. Central Oklahoma, including the Oklahoma City metro area, typically sees snow last anywhere from 1 to 3 days after a moderate winter event, though this can stretch to 4 or 5 days during prolonged cold spells. Urban factors also play a role, as heat from buildings, traffic, and paved surfaces often causes snow on roads and sidewalks to melt faster than snow on lawns or open land. Southern Oklahoma generally experiences the shortest snow lifespan, with forecasters saying accumulation often melts within 24 to 48 hours unless temperatures remain unusually cold, a scenario that is less common but not unheard of. Eastern Oklahoma, with its varied terrain and heavier tree cover, can see uneven melting, where snow disappears quickly in open areas but lingers under forest canopies where sunlight is blocked. Another key factor forecasters emphasize is the temperature of the ground before snowfall begins. If the soil is already cold from previous freezes, snow is more likely to accumulate and remain, while warmer ground can cause melting from below even when air temperatures are low. Wind also plays a critical role, as strong winds can either speed up melting by mixing warmer air downward or preserve snow by keeping temperatures uniformly cold, depending on the broader weather pattern. Meteorologists add that fresh, fluffy snow with a high air content tends to melt faster once temperatures rise, while denser, wetter snow can linger longer by compacting into an icy layer that resists melting. The angle of the sun becomes increasingly important later in winter, as longer daylight hours and stronger solar radiation can significantly shorten snow duration even during cold spells. Forecasters caution residents not to assume that snow remaining on the ground means conditions will stay icy everywhere, since melting during the day can refreeze overnight, leading to hazardous black ice, particularly on bridges and overpasses that cool faster than surrounding surfaces. They also note that forecasts for snow duration are often adjusted after storms end, as small changes in cloud cover or wind can dramatically alter melting rates. In rural areas, snow may persist longer due to less pavement and fewer heat sources, while in cities it may disappear quickly but leave behind slush and refrozen patches. Emergency managers and transportation officials monitor these factors closely, using both forecasts and real-time observations to decide when roads may improve or worsen. Overall, forecasters say most snow events in Oklahoma result in accumulation that lasts between 1 and 3 days, but during major Arctic outbreaks, snow can remain on the ground for a week or more in parts of the state, particularly where temperatures remain well below freezing. They stress that each storm is unique and that residents should rely on updated local forecasts rather than assumptions based on past events. While snow in Oklahoma is often short-lived compared to northern states, forecasters agree that its impact can be significant, especially when melting and refreezing cycles extend hazardous conditions even after the snow itself begins to disappear.